Hi everybody. Today I am going to discuss about Euler's identity. This Euler's identity is considered as the most beautiful equation and as well the most famous formula in all mathematics. Also, it can be said that Euler's equation reaches down into the very depth of existence. So really we need to know what's this Euler's identity. Basically, this identity, it is a special case of Euler's formula. And this formula states that for any real number x, e to the power ix equal to cos x plus I sin x. Seeing the formula, we can say that it relates e with cos x, I mean cosine and sine terms in the field of complex numbers. And geometrically, it can be thought of as a way of bridging two representations of the same unit complex number in the complex plane. So here I am mentioning that it establishes the fundamental relationship between trigonometric function, what you can see in the right hand side, and the complete exponential function which is on the left side. As I told, it can be thought of as a way of bridging two representations of the same unit complex number in the complex plane. So let's see, or let's sketch these geometrical interpretations. It's a circle having real axis as well as imaginary axis. So real axis is horizontal, imaginary axis is vertical. Intersection is O. I have taken 4 intersecting points of the circle with the axis. Here it is 1, minus 1. Here it is I, here minus I. Also, we can find another important things from the formula. It says exponential or imaginary growth, it traces out a circle. Look at it, traces out a circle. And the same path, this is the same path, I mean same this moving circle using this sine and cosine in the imaginary plane. That is the most important points to understand here. So by looking this figure, we are finding lot of things. Here already I mentioned real width cos x, sin x I considered imaginary height. This is real axis, already I wrote RE. Imaginary axis, this is IM, and sin x I called it as a imaginary height, and this is width. Now for every angle x, it gives us a point of a circumference of radius 1, and the sine and cosine as coordinates of this unit circle. This is important points. This cos x, of course, it is a real part, and sine x, already I told it is imaginary part. So combination of a real and imaginary number, it is important point to understand. Combination of a real and imaginary numbers, which together we can call it as a complex number. Also, another important point we need to understand that the real number goes left and right, imaginary number goes up and down. This real growth, it pulls in the same direction. I can say it compounds in our original directions. Compounds in our original direction. This is important. But imaginary growth, it is at 90 degrees. You can see here I. Imaginary growth, it is at 90 degrees. I mean, it rotates us. I put here rotations, it rotates us. So taking any number and multiplying by I will not change magnitude. This is also important point. Taking any number multiplied by I will not change its magnitude. Just direction. It will change the direction. More specifically, I can say it will rotate until we reach I. I mean, we have to move 90 degree upward. As well, the right hand side of this formula describes circular motion with imaginary numbers. Let's view it using x. If we take any number of radians, and plug it into x, what we get is rotation around the circumference of radius 1 of x radians. It's important point, x radians. So the distance crawled around a circle, is an angle in radians. We understand right now, because already I told before. Now here we got lot of points. So our target is to reach how to define Euler's identity. So let's move in the next slide to see what it is actually. So this Euler's identity, it is key values of Euler's formula, one of the key values. I mean with x equal to pi. Because with x equal to pi, Euler's formula gives a beautiful identity. If we start at 0.10, say we start from here, and it is surely on the real axis, and we are traveling pi units. We are traveling pi units from here to here. So I am showing it by a half circle. This one. We are traveling pi units along this circle, I mean half circle. And it is unit circle, radius 1. And this pi, I mean x equal to pi, what it gives us? Here, it gives us, let's see, so as I told, pi units, it means pi radians around the circle. And e to the power I pi, this one, e to the power I pi, already if I put here pi, e to the power I pi, it means starting at 1 and rotating pi to get what? We'll see the result to get what. But first we check cos pi, because already I put here pi in this formula. So this will be x, it will be pi, and here it will be I sine pi. And I put here 0, here I put here cos pi equal to -1. Let's see the table here. Here if you look at, I put highlighted here. If you look at, this is the positions of pi, and here it is showing pi. Result is for cos pi it is -1. For sine pi, because here the value for cos and sine, and sine pi it is equal to 0. So we got the value from this table, confirm it. So basically what it comes, let's remove this. So ei pi, I got +1 equal to 0. This is Euler's identity. And this value is -1. So what ei pi, it means starting at 1, rotating pi halfway around the circle to get to -1. See here, -1. So this is very important to understand. Now this Euler's identity, already we know these equations, these equations. Now we'll tell some special characteristics of this Euler's identity, because why it is so famous? Because this equation, it connects the fundamental numbers. What are those? Let's bring it. E, number that underlines exponential growth. It is very important point. It underlines exponential growth. And its value we know, 2.7183, and it is also called Euler's number, and it occurs widely in mathematical analysis. We have seen in so many places. I, imaginary square root of -1. This is imaginary unit of the complex numbers. Or pi, the number that defines a circle, we know pi equal to 3.1416. Lot of numbers come. And this is fundamental circle constant. 1, the basis of all other numbers. Even we can call it as multiplicative identity. 0, concept of nothingness. From this equation, Euler's identity, we got lot of important informations. Again, it also contains 3 most basic mathematical operations. What is that? Additions, multiplications, exponentiations. That's why this identity, Euler's identity, is very important equations. Now in the next slide, we'll see, because we have here, this is point, this is I, this is 1, this is minus I. So this is actually at point 0 or 2 pi. This is at point 3 pi by 2. This is at point pi by 2. And here it was pi. Already we showed we got minus 1. So let's see when we apply these 3 points, what are the values we get. So same formula, Euler's formula. Before we kept x equal to pi, now we are putting x equal to 2 pi. It is here. As well x equal to 0. It gives the same value. So what it gives actually? Look at, we got cos 2 pi, I sine 2 pi. So what is the value for this? Let's bring the charts. This is the value for 0 or 2 pi. 2 pi, it means 1. And sine 2 pi, it is 0. It is here. So what we got at these positions? We got 1. EI 2 pi. I mean EI in position of x, we put 2 pi. We got value 1. This is one of the key values for Euler's formula. Now we move other 2 points. Say we put here x equal to pi by 2, where it is this one. What it comes? X equal to pi by 2, this formula, pi by 2, pi by 2. What is the value? We know cos pi by 2, it is 0, sine pi by 2, it is 1. Already we know the value. But we can verify this. It is here. 0 and 1. For cos pi by 2, 0. Sine pi by 2, 1. That's what it is. So we got 0 and 1. So what we got here? I multiplied by 1. As I told before, if any number is multiplied by 1 through circular circumference, we will move, and we will move like upward 90 degree, and we will reach it here, that is I. So we have remaining now this one. Let's see what it comes. X equal to 3 pi by 2. I mean, we are here. 3 pi by 2. So with this is also another key values of Euler's formula. So what you will get? 3 pi by 2, 3 pi by 2. So what are the values for cos 3 pi by 2? Let's see. Bring that chart. We are here. 3 pi by 2. We got 0, and here it is minus 1. So we put here 0. Sine 3 pi by 2 equal to minus 1. So easily we got minus I. So this is the value. So we have checked this point, this point, this point, and this point. So let's see all these 4 points in one place. Look at here, putting 2 pi, we get 1, this one. Putting x equal to pi, rotating half circle, we get minus 1. This is Euler's identity. Very special formula. I mean, a special equations, famous equations. And pi by 2, we got I. 3 pi by 2, we got minus I. And the equation what we had before, I wrote like this. I put I, EI, and putting the bracket I put x. Because rewriting formula like this way means this right hand side expression can be thought of as the unit complex numbers with angle x, and the left hand expression can be thought of as the 1 radian unit complex number, 1 radian unit complex number raised to x. That is why I have written like that. And that's all for today. Thanks for watching.